Hello everyone. Today I'm going to walk through Module 21 and problem solving using C. Today I will be discussing mastering C functions, one of the most functional concepts in C programming. Functions are often called the building blocks of programs because almost every large software system is constructed using multiple functions working together. Instead of writing one long and difficult program, functions allow us to organize logic into smaller, meaningful sections. This improves program structure, reduces complexity, and makes software easier to develop and maintain. Understanding functions is essential not only for academic programming but also for professional software development. Now we are going to see why functions, the power of modularity. Functions form the foundation of structured programming in C. A function is self-contained block of code designed to perform a specific task. Each function focuses on one responsibility, which follows an important programming principle known as modularity. Modularity means dividing a large problem into smaller independent modules that work together. So first we are going to see what is meant by breakdown complexity. In large programs, managing thousands of lines of code becomes difficult. Functions solve this problem by breaking programs into smaller logical units. For example, instead of writing one massive program for a banking system, we can create separate functions for login, balance checking, transaction, and reports. This makes programs easier to design and understand. The next one is easier debugging. When errors occur, functions help isolate problems quickly. Instead of searching through the entire program, we only examine the specific function responsible for the task. This reduces debugging time and minimizes accidental changes to other parts of the program. The third one is code reusability. Write code once and use it multiple times throughout your programs. One of the greatest advantages of functions is reusability. Once a function is written and tested, it can be reused multiple times without rewriting the same logic. For example, a function that calculates an average can be reused whenever averages are required. And the fourth one is improved readability. Well named functions make your code intent crystal clear, improving collaboration and long time maintainability. In other words, well named functions act like meaningful sentences in a program. Names such as calculate total, display menu, or validate input clearly explain program behavior, making collaboration and maintenance easier. Next, we are going to see the three pillars of C functions. The three pillars of C functions are function prototype, function definition, function call. To use functions efficiently, we must understand these three essential components known as the three pillars of C functions. So first we are going to see what is meant by function prototype. The function prototype informs the compiler about a function before execution began. The what tells the compiler about the function existence, its return type, and the type of its parameters. In other words, it specifies what type of value the function returns, what is the name of the function, and the types of parameters it accepts. The next one is function definition. The function definition, the how, contains the actual code, the body that performs the function task when executed. The function definition contains the actual instructions that perform the task. This is where the program logic is written. The third one is function call. The when executes a function's code and transfers control to the function at runtime. The function call activates the function during runtime and transfers program control to it. So these are the three pillars of C functions. Next, we'll be seeing what is meant by function prototype. What it does, it informs a compiler about a function's signature before it's used or defined. This is essential for type checking and preventing compilation errors. Function prototype ensures that the function is used correctly even before its implementation appears in the program. So function prototypes provides various key advantages or benefits. They enable calling functions before defining them. They enable compile time checking. They prevent parameter mismatch errors. They help organize large multi-file programs. So now we are going to see the general structure of the function prototype. First, we'll be having return type, next the function name and the parameter list. The syntax includes return type, function name and parameter list and a terminating semicolon. We have seen example int add int a comma int b semicolon. Int returns an integer, add is a function name, int a and int b are two integer parameters. This function add tells the compiler that add returns an integer and requires two integer inputs. Next, we are going to move into function definition. This is where the actual implementation happens. What it does, it provides the actual code that the function will execute when called. This is where the function logic lives. In other words, the function definition contains the actual instruction executed when the function is called. This function transforms the blueprint into working logic. A function definition includes return type, function name, parameter list, function body enclosed within braces. So this is the basic structure of the function definition. We are going to have a return type, we are going to have a function name followed by the parameter list. Within the braces is the actual code where the logic of the function lives. Here we are going to see an example, complete example of add, int a comma int b, int sum is equal to a comma a plus b, return sum. So this function sum receives two values, performs additions and returns the result to the calling function. The next example we are going to see is a void greet. This function is just going to display a hello message. This function performs an action printing a message but does not return a value. Therefore, its return type is void. Next, we are going to move to the next slide, function call. A function is called to execute its task. It can be invoked from main or other functions, transferring control and potentially returning results. A function does nothing until it is called. A function called transfers execution control from the calling function, usually main, to the called function. The syntax is result is equal to function name argument. This is how we are going to call a function. Example how we are going to call a function. We are going to declare an integer variable total, and total is equal to add 5 comma 3. We are going to call the function add by passing two parameters 5 comma 3. After execution, the total will be having the value 5 plus 3 is equal to 8. So what happens during execution? Arguments are passed to parameters. The function performs computation. The result is returned and stored in total. So this is how the function call happens. Now, what is how the function flow happens? How the control transfer happens? So for the first, the prototype informs the compiler. Then the main calls a function. Control jumps to the function definition. The function executes instructions. Control returns to the calling location with the result. This mechanism is known as control transfer. In the first step, what we are going to do, we are going to declare the prototype of the function. Function signature declared before main. Then call is initiated. That is, we are going to call the function from the main or from any other function. Then the function execution jumps to function definition. Then execution happens. The function body executes and processes data. And after execution is completed, the control is returned to the caller with result. So this is how the control transfer happens. We are going to see an example, the same example what we have seen earlier, adding two numbers. This is a complete code. So this is a function prototype. Before main itself, we have declared a function int add, int in, that indicates that the name of the function is add. It's going to take two parameters, two values of integer type, and the result will be again int. In the main, what we are going to do, we are going to declare x and y and sum. And sum, by using sum, we are going to call the function. This is where the function call happens. Next, by using printf statement, we are going to print the result. So the function definition, what we are going to do, we are going to perform the sum of a plus b, and we are going to return it to the calling function. So how it works? First, the function declaration declares add, then main initiates variables, add called with x and y values, function returns x plus y, result is printed as sum is equal to 30. So this is how the program execution happens. Now, the main points of this function. Functions divide large programs into manageable units. That is, modularity is power. That is one of the main point in functions. The next one is library versus define. Use library functions like printf for common tasks, but create custom functions for program-specific logic. Library functions solve common problems, while user-defined functions provide customized solutions. Next one is the third essential components. Prototype, definition, and call must work together correctly. The fourth one is recursion, that we are going to see in the next presentation. Recursion is powerful. Recursive functions solve problems by breaking them into smaller identical and sub-problems, mastering this technique. So always declare prototypes before main when definition appears later. This ensures correct compilation and improves program reliability. In conclusion, functions are not just a programming feature. They represent the foundation of structured and modular programming. By mastering functions, programmers can create programs that are cleaner, reusable, scalable, and easier to maintain. A strong understanding of functions prepare you for advanced topics such as recursion, file handling, and large-scale software development. Thank you.